Welcome to the Identifying and Protecting Confidential Data module of the Symantec Data Loss Prevention 15.7 Planning, Implementation, and Administration course. Organizations are inundated by data in today's modern network environments, and since it is not practical to try to protect all of this information, each organization will need to determine what data is most important to them and what impact the loss of this data might have on their business. And this can be a complicated and challenging task. Before an organization can monitor and prevent the loss of critical or confidential data, they must first define what data they consider to be critical or confidential in the first place. This requires the DLP program administrator to work with data owners to identify data accurately and comprehensively. After this definition has been established and specific examples of data have been identified, the organization can configure the DLP product to recognize critical and confidential data wherever it exists on the network. It is usually not difficult for organizations to create a long list of all the different types of confidential data they need to protect. However, rolling out a data loss prevention program can be an ambitious and time-consuming undertaking, so it is usually not possible to immediately begin protecting all data at once. Additionally, the loss of some types of confidential data can have a far more serious impact upon an organization than others. Therefore, it is a good practice to prioritize data based on the level of impact its loss would have on an organization, and then focus on protecting the higher priority data first. To help prioritize data, Symantec recommends detailing the impact of data loss for each scenario you are considering. Some examples might include heavy fines, loss of customer confidence, loss of trade secrets, and loss of competitive advantage, negative impact to the brand, and customer attrition. Next, rate the severity of each consequence on a scale of 1 to 5, with 1 indicating low severity, meaning little overall impact to the organization, and a 5 indicating high severity, meaning significant financial, legal, or competitive advantage impact. Input from organizational units and executive-level sponsors is critical during this exercise. With the help of those closest to the data and those guiding the organization, this exercise should provide the perspective needed to prioritize the confidential data to protect and to select the 3 to 5 data loss prevention policies to implement first. Later, you should have an idea of the subsequent policies to implement and their order of deployment. In this module, we'll be covering the following topics: how to configure Symantec Data Loss Prevention to recognize confidential data, what detection methods DLP provides in order to identify and describe the confidential and sensitive data in the organization, how to use policy templates, and what response rules are available to respond to incidents when they occur. Configuring Symantec Data Loss Prevention to recognize confidential data. In this module, we'll discuss the purpose of policies and policy groups, we'll identify the various data detection methods offered by Symantec DLP, and describe the function of group rules and response rules. After the DLP project team has established their definition of critical data, identified who owns the data, and prioritized which data to protect first, the next step is to prepare to detect data wherever it exists in the organization so it can be protected. In order to detect data, it must first be described so the DLP product knows what to look for. Symantec DLP enables organizations to describe, detect, and protect data through the use of policies. Symantec DLP policies enable you to specify one or more rules to define the data to detect and the automated responses you want your detection servers and endpoint agents to execute upon detection. Additionally, policies document and enforce security management practices. Symantec DLP captures incidents when it detects data that violates one or more rules of a policy. Incident records contain a list of matches, which are the specific elements of a message or file that violate policy. For instance, confidential text or a particular attachment size or type. Note that data can trigger multiple incidents in cases where it violates multiple rules within one or more policies simultaneously. You can create policies from scratch or use templates to help you quickly deploy policies in your organization. You can also share policies across systems and environments by importing and exporting policy rules and exceptions as custom templates. Whether you start from a blank policy or use a policy template, all policies consist of 3 main parts: detection rules, group rules, and response rules. Additionally, each policy must be assigned to a policy group. Detection rules use conditions to describe the different patterns, formats, and contexts in which confidential data can occur within an organization. Detection rules leverage Symantec Data Loss Prevention's detection technologies to achieve near-perfect accuracy in incident detection. Each of these detection methods will be discussed in more detail later, but this table provides a brief overview. Group rules use conditions to identify the users, groups, message senders, and message recipients to whom a policy applies. Additionally, group exceptions enable you to exclude specific groups of users from a policy. Identities can be matched by email address, user ID, IM screen name, and IP address. There are 3 methods for using group rules in Symantec DLP. Pattern matching allows you to define single-use sender, user, and recipient patterns to match against user identities, or you can create reusable sender, user, and recipient patterns that can be used across all policies. Directory group matching can be used to detect large groups of users who can then be included or excluded from detection based on specific identity information. For example, you can use DGM to detect and include users with certain employment statuses, or ignore and exclude users if they reside in countries with stricter privacy laws. Finally, you can define user groups based on Active Directory groups, or OUs. You can schedule synchronization with Active Directory, so any changes to a directory server are reflected in the policies automatically. After a user group is populated, it can be associated with sender, user, and recipient detection rules or exceptions in a policy. Response rules can be added to a policy to take automated actions on incidents. For instance, if a policy is violated, a response rule can block the transmission of a file containing sensitive content, or it can quarantine or encrypt the file. Response rules are created, modified, and managed separately from the policies that use them, and this decoupling makes it possible to update and reuse response rules across policies. Response rules can be run automatically, or you can configure smart response rules that incident remediators can execute on demand. You can also implement conditions to control how and when automated response rules execute. Policies are deployed to detection servers using policy groups. Policy groups limit the policy's incidents and detection mechanisms that are accessible to specific administrative users. Each policy will belong to one policy group. When you configure a policy, you assign it to a policy group. You can later change the policy group assignment, but you cannot assign a policy to more than one policy group. In summary, Symantec DLP uses policies to specify the data to detect and the automated responses to be executed upon detection. Policies consist of detection rules, group rules, and response rules. Each policy must also be assigned to a policy group. Detection rules use conditions to describe the patterns, formats, and contexts in which confidential data can occur within an organization. Group rules use conditions to identify the users, groups, message senders, and message recipients to whom a policy applies. Response rules can be added to a policy to take automated actions on incidents. Policy groups limit the policy's incidents and detection mechanisms that are accessible to specific administrative users. Detection methods. In this topic, we'll discuss the different types of DLP detection methods available and their common use cases. Described content matching, or DCM, enables organizations to detect a wide range of both structured and unstructured data. The DCM detection method uses keywords, lexicons, pattern matching, file types, file sizes, sender, recipient, and network protocol information to detect data loss incidents. DCM is useful in situations where it is difficult or impractical to collect and index all the content that needs to be protected. DCM's content rules include the following: keywords, meaning simple keyword lists or extensive lexicons; data identifiers, which are patterns with validators that identify common numbers, such as ID numbers and credit card numbers; regular expressions, which are useful tools when there is no data identifier available for more exact content matching; and classifications, metadata or tags that are applied to email messages or common document file types. DCM's context rules include contextual attributes, which are captured by supported services that are integrated with Symantec DLP's Cloud Detection Service. DCM's user identity rules include sender-user matches pattern or recipient matches pattern, which can match domain, email addresses, newsgroup patterns, IP addresses, Windows usernames, or URL domains. File property rules can include file type, file size, and file name. Transmission method rules include the following: protocol or endpoint monitoring, which enable you to detect network messages based on the communications transport method, such as email, SMTP, FTP, HTTP, etc. Endpoint device class or ID detection rules detect when users move data from an endpoint computer to endpoint devices. Endpoint location detection rules enable you to specify whether the endpoint computer is on or off the corporate network. Keywords can be used to identify data files with important content, using either simple keyword lists or extensive lexicons. Keyword matching includes proximity matching, which detects relationships among keywords based on their distance from each other. Using keyword proximity matching, policy author can define a pair of keywords and specify a word range between them. If the words occur within that range, a match is triggered. Data identifiers are patterns with validators that identify common numbers such as government-issued ID numbers or credit card numbers. When existing data identifiers are not specific or exact enough, you can also configure detection conditions to use a regular expression to match content. Symantec DLP's classification rules enable the detection of Symantec Information-Centric Tagging or ICT metadata or tags, which can be applied to email messages or common document file types. Tags typically consist of three components: the organization, representing the entire company or logical divisions within a single company, a scope, typically a functional group such as payroll or engineering, and a sensitivity level, which means the degree of sensitivity of data within files, ranging from 1, the least sensitive, to 9, highly sensitive. Symantec DLP's cloud detection service can perform detection on attributes sent from supported third-party services. Currently, Symantec CloudSOC and Symantec Web Security Services, or WSS, are supported for integration with Cloud Detection Service, and these services can send a combined list of attributes that fall under the broad categories of general, user, data exposure, data transfer, and custom attributes. User identity detection matches patterns in messages from email senders and recipients, Windows users, instant messaging users, URL domains, and IP addresses. File property rules allow files to be identified by type, name, or size. Symantec DLP can recognize over 200 different file types for most documents, which means that even if users change the file extension, DLP can still detect the file type accurately. For protocol or endpoint monitoring, you can configure detection conditions for Network Monitor and Network Prevent to monitor and block network traffic based on the protocols that DLP recognizes out of the box, as well as any other protocols you add. For Endpoint Prevent, you can configure conditions to monitor and block traffic at the client level, for instance, local email clients. With Endpoint Prevent, you can also monitor and block endpoint destinations, such as local drives, CD or DVD drives, removable storage, for instance USB drives, network shares, printers, fax machines, clipboards, and cloud storage. DLP also enables you to detect or exclude specific endpoint devices based on described device metadata. You can configure a condition to allow endpoint users to copy files to a specific device class, such as USB drives only from a single manufacturer. Endpoint location monitoring can be used to determine whether an endpoint machine is on or off the corporate network. DLP's Exact Data Matching Detection Method, or EDM, enables organizations to detect personally identifiable information stored in structured data sources, such as databases or directory servers, or structured data files, such as CSV files or spreadsheets. This data can be added to an EDM index, and the index can be referenced in a Symantec DLP policy, enabling organizations to detect combinations of information, such as customer first name, last name, and credit card number in outbound emails, or in files residing on Windows file servers. To detect exact data, Symantec DLP requires a special indexed version of the data. An EDM index is a secure file or set of files containing hashes of the exact data values from each field in the data source, along with information about those data values. The index does not contain the data values themselves, so it is absolutely secure. The EDM index is deployed to all detection servers where it is used for detection. You can refer to this index in a policy that is configured to detect specific combinations of fields from the data source. The detection server then uses the indexing algorithm to hash input content, for instance an email, and then analyze the hashed content against the index to find matches. If an employee sends an email containing specified data combinations, Symantec detects the confidential data and creates an incident. Exact Match Data Identifiers, or EMDI, are essentially validations of data identifier patterns using an indexed data source. As discussed earlier, data identifiers are patterns with validators of their own that identify common numbers, such as ID numbers and credit card numbers. EMDI adds another level of validation, an indexed data source containing specific values for the system or custom data identifier type you're looking for. For instance, DLP has a built-in credit card number data identifier that can detect credit card number patterns with a high degree of accuracy. You can increase that accuracy by indexing a data source that includes specific credit card numbers that you want to detect, such as your customers' credit card numbers that are stored in a database as part of business transactions. This EMDI index or profile serves as an additional check or validation for that data identifier. In addition to structured data, such as databases and spreadsheets, organizations can also generate vast amounts of unstructured, confidential, and proprietary data that take many forms. Some examples of such unstructured data can include design documents, CAD drawings, and financial reports. DLP's Indexed Document Matching, or IDM, enables organizations to fingerprint and detect sets of unstructured files like these. IDM supports two forms of matching: exact file matching, which is based on the binary signature of files, and partial file content matching, which is used to detect discrete sections or passages of extracted and normalized file contents. In the example shown here, an index built upon sample documents representing confidential merger and acquisition data is used to detect inappropriate email content. Vector machine learning, or VML, is a powerful tool that enables organizations to detect and protect unstructured data by performing statistical analysis to determine if analyzed content is similar to sample content already introduced into the Symantec DLP system. Unlike other detection technologies, with VML it is not necessary to locate and fingerprint all of the data that needs to be protected, nor is it necessary to describe it and risk potential inaccuracies. With VML, the system is trained to learn the type of content it needs to protect based on example documents. VML detection is based on a VML profile, and a VML profile is created by uploading a representative amount of content from a specific category of data. The system scans the content, extracts the features, and creates a statistical model based in part on the frequency of keywords in the example documents. At runtime, the system applies the model to analyze and detect content that has features that are statistically similar to the profile. Form recognition enables organizations to detect confidential information in hand-filled, printed, or electronically fillable forms, such as tax forms, state identification applications, and so on. Symantec DLP's form recognition technology is based on image detection, detecting differences between a baseline graphic, for instance an image of a blank form, and modified versions of that graphic. DLP can perform optical character recognition, or OCR, on data at rest and on network traffic. Using OCR, Symantec DLP can extract text from PDFs, Microsoft Office documents, and bitmap images, and then analyze the extracted text against your DLP policies. Use cases for OCR can include performing detection on text extracted from digitized documents, applications, photos, and diagrams or figures. In summary, Symantec DLP uses a variety of detection methods to identify and describe confidential data. Described content matching (DCM) will use keywords, data identifiers, file properties, and other attributes to identify important data. Exact data matching and exact match data identifiers use indexes of existing structured data in order to match user data. Index document matching, or IDM, indexes unstructured data to match against user data, while vector machine learning, VML, can identify statistically similar documents and data based on learning examples without having to have an exact copy. Form recognition and optical character recognition, or OCR, can also be used to identify text and data from scanned forms and images. Policy templates. In this topic, we'll discuss DLP's library of policy templates and how to use them to create policies easily and conveniently. Policy templates are predefined packages of detection rules that have been organized for user convenience. Creating a policy from a template allows you to save time and avoid errors because the detection rules and methods are already defined and validated. Many policy templates are based off of well-known sets of regulations, such as the U.S.'s Gramm-Leach-Bliley Act and the Health Insurance Portability and Accountability Act, or HIPAA, or the European General Data Protection Regulation, or GDPR. Other templates are based off of more generic needs, such as customer data protection, employee data protection, or source code protection. Note that you are also not limited by the existing templates in Enforce. You can create and then export any of your own policies as a template to be reused in the future for variant policies based off of your original design. Response rules. In this topic, we'll discuss how DLP's response rules are used to create meaningful responses whenever a policy rule is triggered. Symantec DLP provides several mechanisms that take action to prevent the exposure of data whenever a policy violation occurs. These components are called response rules, and they are available for data in motion, data at rest, and data in use. Symantec DLP performs protection actions using response rules, which dictate what to do when an incident is detected. Response rules enable your organization to prevent and respond to data loss incidents appropriately. There are two types of response rules: automated and smart responses. The system performs automated responses when it evaluates incidents. Such response rules can be based on a set of conditions, such as agent connection status, incident type, match count, protocol, or severity. These types of actions can be performed by detection servers, whether on-premise or in the cloud, and endpoint agents. In the context of real-time protection, automated responses are available for data in motion, data in use, and data at rest. Smart responses are ideal for situations that require human remediation and are therefore manually invoked by the incident responder and executed by the enforce platform. A great benefit of smart responses is that an organization can respond to incidents based on detailed information and context provided by the incident snapshot. Smart responses are available for every type of data loss incident, but are especially useful for actively protecting data at rest. For instance, an incident responder can trigger an on-demand smart response rule to move multiple files with confidential information to a secure location. One common and useful category of response rules are user notifications. When a user handles confidential data in a manner that violates security policy, Symantec DLP can alert the user of the infraction immediately with an on-screen pop-up, or via email message, or marker file that replaced a quarantined confidential file, or tags that educate the user about the incident and what to do next. Effective use of notifications can measurably reduce risk to an organization's sensitive data. In fact, many Symantec DLP customers have reported a significant reduction in data security incidents after implementing user notifications. There are two categories of options: simple notifications, such as sending an email to a user who has violated policy, and notifications that are part of a combined response, such as a quarantine response rule that moves a sensitive file to a secure location and leaves an explanatory marker file in its place. For email and MTA integration, Symantec DLP has two options for preventing data loss. The block SMTP message response rule blocks email messages that contain confidential data or significant metadata, as defined in your policies. You can configure DLP to block the message by returning a permanent delivery error, or send a customized permanent delivery error message to the sender, and/or redirect the original message to another destination. The Modify SMTP message response rule modifies email messages that contain confidential data or significant metadata. You can use this action to modify the message subject or add specific message headers to trigger further downstream processing or rerouting, such as message encryption, message quarantine, or message archiving. There are three additional data in motion protection actions available when interacting with a web proxy and Network Prevent for Web. The Block FTP Request action blocks FTP requests that contain confidential data or significant metadata. Through the Block HTTP or HTTPS action, you can block HTTP or HTTPS transactions and display a customized block message in the web client. The Remove HTTP and HTTPS content response rule lets you remove confidential content from an HTTP or HTTPS transaction. DLP policies can also be applied to data in motion within cloud applications through the integration of another Symantec product, CloudSOC, along with Data Loss Prevention's Cloud Detection Service. CloudSOC is Symantec's Cloud Access Security Broker solution, or CASB, which ensures that due diligence, oversight, and security can be applied to the use of Internet repositories, collaboration sites, and other supported cloud services. Some of the CloudSOC-specific response rules for dealing with data in motion in cloud environments include the following. Block Data in Motion response rule allows blocking data from being uploaded to or downloaded from cloud applications. The Redact Data in Motion response rule redacts content from data uploaded or downloaded from cloud applications. Also, custom actions using JSON can be performed on data uploaded to or downloaded from cloud applications. For endpoint laptops and workstations, Endpoint Prevent also provides some out-of-the-box automated response rules for protecting confidential data in use on the endpoint. The Endpoint Prevent Notify response rule educates the user about the violation that has occurred, but does not block or stop movement of the data. This rule creates an on-screen notification, a pop-up window, that contains information about the violated policy, and the user must provide a justification for the action. The Endpoint Prevent User Cancel response rule lets users allow or cancel actions that violate certain policies. In addition, the user must provide a justification for the action. An incident snapshot is created no matter which choice is made. The Endpoint Prevent Block response rule stops the movement of data that violates policy. This rule also optionally displays an on-screen notification that contains information about the violated policy, and the user must also provide a justification for their action. The Endpoint Prevent Encrypt response is available to customers who have an encryption service integrated. If the service is configured, then the response option is unlocked. This ensures that any confidential data that is moved can be permitted, but only if it is encrypted. Additionally, it ensures that the data can only be read on machines capable of decrypting the content, or by non-corporate devices when the user is authenticated. DLP also provides the Endpoint Flex Response technology, a flexible platform that allows the creation of customized actions to perform incident remediation, for instance, encrypting a file being copied to a USB device. DLP also offers a comprehensive set of options for the protection of data at rest. In any organization, the information that fuels daily operations are frequently kept in repositories, such as file systems, databases, and content management systems, mostly on-premise, but with a growing tendency towards the adoption of cloud solutions as well. These repositories almost always contain confidential information, and massive data breaches have occurred either after malicious outsiders have infiltrated such information repositories or due to mistakes and carelessness of information owners and users. DLP offers effective controls for identifying and protecting data at rest on-premise. These controls can be triggered in real time, immediately after the information has been found, or on demand by the incident handling team. Some of the actions available for protecting data at rest include the following: copying the file, quarantining the file, encrypting files, tagging and classifying files, or custom flex response actions. DLP's Cloud Storage Discover also supports scanning and protecting confidential files residing in box cloud storage. The options for protective action here are 1. Applying a visual tag to sensitive files, and 2. Quarantining confidential files. For the quarantine response, files are moved from their original location and quarantined in either a controlled box repository or an on-premise folder. Marker files can optionally be left behind in place of the quarantined item. For data at rest in cloud applications, the integration of CloudSOC through the DLP Cloud Detection Service also allows for some specific response rules, such as quarantining, removing shared links, and encrypting. Response rules can also be configured to take action on the file application permissions, whereas the file will remain unchanged. Some actions in this category include the prevention of downloading, copying, and printing, and controlling file access rights to various users. In summary, Symantec DLP's policies use response rules to determine the automatic response to execute when an incident is triggered. These response rules can be completely automated or can be used as smart responses for incident remediators to execute manually when needed. The available response rules differ depending on the context and incident type. Transmissions over SMTP, HTTP, HTTPS, or FTP can have the content blocked or edited automatically. Endpoint agents can automatically block actions that violate policy, or can simply notify the user that a violation could occur and allow the user to cancel or provide a business justification for their action. Files in cloud environments can be blocked, encrypted, quarantined, or have their access rights altered whenever confidential data is discovered. Data found in network repositories can also be quarantined, encrypted, or tagged. In summary, Symantec Data Loss Prevention uses policies both to identify and protect important and confidential data. Each policy consists of multiple parts. Detection rules are specific rules to identify and describe different types of confidential and sensitive data. Group rules define who the policy does or does not apply to, and response rules dictate what happens when the policy is violated. DLP supports a variety of detection methods to identify and describe both structured and unstructured data in many different forms and locations. Different detection methods can be combined together to create policy rules that trigger independently. Policy templates can also be used to design and implement policies very quickly and conveniently, with many of the commonly used rules already in place. Response rules define the appropriate response when a policy is violated. These can include blocking, user notification, or quarantine. Thank you for joining us. This concludes the Identifying and Protecting Confidential Data module of the Symantec Data Loss Prevention 15.7 Planning, Implementation, and Administration course. In this demonstration video, we'll take a quick tour of the Enforce Administration Server Console interface and how incident management and policy creation happens. The home page, seen upon logging in, contains a dashboard with various statistics, charts, and graphs, all of which are user configurable. On the Incidents page, we can see all of the recent incidents that have been tracked by the Enforce system, organized by incident type, along with additional information such as sender and recipient, along with filtering controls that allow you to view subsets of incidents by date or type. Clicking on an incident takes you to the Incident Snapshot, which contains all of the detailed information about incident details, including when it occurred, the type of incident, the user that triggered it, and the specific data matches that violated policy rules. We can see these policies on the Manage, Policy List page, which shows all of the current policies defined in the system and whether they are active or not. Specific policies can be enabled or disabled simply by clicking on the appropriate icon in this list. Policy details can be viewed by clicking on a particular policy. The policy view will show you a list of the current active rules, which can be created or edited here. Clicking on a specific rule will allow you to edit rule configurations, such as how to determine incident severity, and specific conditions about when the rule will apply. In this demo video, we will walk through how to create and configure a new policy. First, we will go to Manage, Policy List, and click the New button to create a policy. Here we can select to create a blank policy or create a policy from a template. We will first create a blank policy and configure it to work with Social Security numbers. To create a new rule for our policy, we'll click the Add Rule button and then select the appropriate detection or identification method. In this case, we will use a data identifier that has been configured to look specifically for U.S. Social Security numbers. Once a rule has been created, we can give it a name and then determine how we want to judge incident severity. By default, any discovery of a Social Security number in important documentation will be judged as high severity, but we can create a more nuanced approach by altering the severity according to the number of matches. In this case, we will judge a high severity incident to be anything that contains more than 30 Social Security numbers. Less than 30, but more than 10, will be judged as a medium severity incident, whereas anything under 10 will be marked as low. Once the rule has been added, we can add in a response rule, which is what we want the system to respond with once a policy violation has been detected. In this case, we will set up a block email action for any network policy violations, meaning that if any email has been sent out of the system with an attachment that contains Social Security numbers, the system will automatically block the email. You can also create policies direct from a template, which is helpful for quickly and conveniently creating policies that have many commonly used settings. To do this, we will click on the New button and then select Add a Policy from a Template. This page lists all of the available templates, which cover a variety of legal and regulatory categories from the U.S. and other countries around the globe. Examples include the U.S.'s HIPAA, the Health Insurance Portability and Accountability Act, which governs medical records, and the European General Data Protection Regulation, or GDPR. In this case, we will create a new policy based off of the HIPAA template. By selecting the template and going to the configuration screen, we can see that a number of policy rules have already been pre-configured. These rules contain a number of helpful detection and identification strategies for determining medical records, including drug keywords, treatment keywords, disease keywords, and drug codes. These pre-created rules can be added to or modified in order to tailor the most robust and effective health record detection strategy for your organization. In this video, we will demonstrate how Symantec Data Loss Prevention policies can be used to protect confidential and sensitive information from leaving the organization. In this example, we have an employee named Joe User who's friends with Sylvia at another company. Joe has access to a number of confidential files containing personal information, including the spreadsheet shown here, which contains a number of Social Security numbers, account numbers, and other personal information that should be protected and should not leave the company. Here we will demonstrate under normal circumstances, Joe is able to attach this file containing personal information to an email to Sylvia outside the company, and we can see that he is able to send this email with the improper attachment, and it shows up in Sylvia's inbox without issue. We can guard against this misuse of data by implementing a DLP policy inside of the Enforce Administration console. This policy is designed to check outgoing emails and attachments for confidential and sensitive data. Looking at the policy details, we can see that it has been designed with a rule to identify U.S. Social Security numbers in any form, context, or volume. Additionally, we've designed this policy to have a response rule that when confidential data, such as Social Security numbers, have been found in an outgoing attachment or email, that email will automatically be blocked. Here, we will now enable this policy and see how this affects Joe's capability of sending confidential information to Sylvia or anyone outside of the company. As before, Joe will attempt to send an email with the same attachment to Sylvia, but in this case, the existing policy will scan the email and the attachment and make sure it doesn't violate any policy rules. Because the scan reveals that the attachment contains Social Security numbers, an incident is created, and the appropriate response is triggered. In this case, the email is blocked, and the email and the attachment never arrive in Sylvia's inbox. Instead, Joe receives an error message saying that the email could not be delivered, and also containing a custom message written by the DLP administrators explaining the violation of policy. At the same time, we have also configured the policy to forward any offending emails to IT security, so they can be informed of any attempt, whether intentional or unintentional, to send confidential information outside of the company. IT security is now free to follow up with Joe and/or his manager to perform any education or discipline that is necessary for this policy violation.